When some of us think of the Middle East and North Africa, we might picture images of sand dunes stretching as far as the eye can see, or giant oil rigs pumping black gold from the ground. But for the people who live here, the most critical resource is water. To some geographers, the map of the world's precipitation is the most important map for understanding life on Earth. And nowhere is this more true than in the Middle East and North Africa, or MENA, which includes vast deserts like the Sahara. With maps of precipitation and available water on the Earth's surface, we can think about why people are clustered where they are, and the conflicts water can create. While controlling surface water, like lakes and rivers, gets a lot of attention, there's an invisible source of water creating tensions and challenges too. In fact, groundwater stored in the ground supplies nearly half the world's drinking water. And in the Middle East and North Africa, an estimated 90% of fresh water, whether in rivers or underground aquifers, crosses one or more international borders, involves multiple stakeholders and political conflicts, and is embedded in a complicated physical geography. All of which make managing water, especially water we can't see, an extraordinary challenge. I'm Alize Carrere, and this is Crash Course Geography. Over the last 2 episodes, we've been exploring water and the different ways we're connected to it. And in this final water episode, we'll tell one more part of water's story. Like rivers on the surface that unite and divide us, whether we use groundwater to control others or choose to share can shape our path to peace. In fact, only about 2.8% of all the water on Earth is fresh water, or water that doesn't contain a lot of salt that we can use for drinking and growing things. All the other water on Earth is salt water in the oceans. Of that fresh water, over 2/3 of it is locked up in ice sheets and glaciers, and a tiny amount is found in rivers and lakes. The rest lies beneath Earth's surface. So groundwater makes up a little more than 0.5% of all the water on Earth, yet it's the largest potential source of fresh water we've got in the entire hydrological cycle that moves water between the 4 Earth systems. Looking at a map of groundwater use, we'd see that's not such a great thing for large parts of the Middle East and North Africa, which is the most water-scarce region in the world. Several countries have a groundwater stress rate of more than 100%, which means we're using up the groundwater resources faster than they can be refilled or recharged. You see, groundwater is the part of the hydrosphere stored within the lithosphere, but it's still connected to the other spheres on and above the surface. Precipitation that absorbs into the ground before reaching a river can recharge aquifers and other underground reservoirs. So groundwater isn't an independent source of water, like we saw last time in Jakarta. And this connection between groundwater and precipitation is specifically an issue because the Middle East and North Africa sits under a subtropical high-pressure belt, which means very little rain falls, and the main way we describe the climate is arid, or dry. There can even be a moisture deficit, which is when the amount of moisture that evaporates is more than returns as precipitation. When it does rain, any extra water that absorbs into the ground moves through a zone of aeration, where the rocks and soil aren't fully saturated, and there's both air and water. As gravity pulls it deeper, the water eventually reaches the zone of saturation, which is the layer where every space in the bedrock, regolith, and soil are filled with water. We call the very top of the zone of saturation the water table, and this sort of imaginary line can shift depending on where we are. The water table might be deeper or shallower depending upon the physical characteristics of the region, the input from precipitation, and the output into lakes, streams, and marshes, or during periods of drought. Like in the Middle East and North Africa, precipitation patterns and rivers like the Nile, Tigris, and Euphrates guide where there's agriculture and where people settle. But life can also flourish in oases where erosion has lowered the land surface, and a relatively high water table means the zone of saturation is close to the surface. How much water can be absorbed in the zone of saturation, or its porosity, and whether or not it's permeable and lets water flow, depends on the makeup of the soil and rock. That includes the mineral composition, how the particles are arranged, their grain size, and what's between them. In fact, aquifers aren't big pools of water beneath the surface. They're really permeable rock masses that easily store groundwater and act as a water supply. Like the groundwater that supplies those oases is often recharged by rainfall entering other aquifers far outside the desert. The groundwater very slowly moves down and horizontally through porous soil and rock in mountainous areas. In general, layers of sedimentary rock like sandstone or limestone, or deposits of sand and gravel, are good aquifers because they're permeable and can hold a large amount of groundwater. But on the other hand, clay and shale beds are relatively impermeable and are called aquitards. So, though we can find groundwater at almost every location on land that receives rainfall, the amount of precipitation, the rate of evaporation, the character of the ground, the amount and type of vegetation, and the porosity and permeability of soils and rocks make it a vastly unequal resource. And where major water resources like aquifers and rivers are actually distributed is complex, especially when they cross one or more international borders. Take the Arab-Israeli conflict, which is the ongoing political tensions and military conflicts between Arab nations and Israel, and one of the longest and most complex disputes in the world. It's often seen as a conflict over land, but it's also about life-giving water on and beneath the land. This includes the eastern Mediterranean region, often called the Levant, where highly productive aquifers made of limestone and dolomite that cross boundaries create some unique challenges. There have been many ancient civilizations in this region, and some of the earliest references to water use, laws, and management can be found in the Code of Hammurabi, written in approximately 1780 BCE. But today we'll focus on more recent events, though for a more thorough history you can check out that episode from Crash Course World History too. The Six-Day War between the countries we call Israel, Egypt, Syria, and Jordan in 1967 rearranged not only the region's political landscape, but the water resource landscape, particularly in favor of Israel. Among other land, Israel gained control of the entire West Bank from Jordan, including sources of water vital to Jordan, Syria, Lebanon, Palestine, and Israel. In particular, the Western Basin, the Northeastern Basin, and the Eastern Basin, which make up the West Bank's aquifer system. Together, these basins make up the Mountain Aquifer, which is a shared Israeli-Palestinian groundwater resource that lies under both Israel and what the United Nations calls the occupied West Bank, where many Palestinians live. It's replenished mostly by rain and snow absorbing into the ground in the West Bank, and flows north and west toward Israeli territory in one direction, and east towards the Jordan River in the other direction. The Mountain Aquifer is the largest and also one of the most important groundwater resources for Israel, and the sole remaining water resource for the Palestinians. But since 1967, when Israel began occupying the West Bank, strict water use policies have come into effect, creating an inequitable system in which Palestinians' access to this shared resource is highly regulated and restricted. Under the interim Oslo II Accords of 1995, Israel retains control of all water resources. They utilize 80% of the water from the aquifers under the West Bank, limiting Palestinians to 20%. This allows the average Israeli to use about 300 liters of water per day, while the average Palestinian in the West Bank uses an average of 73 liters. For reference, the World Health Organization says a minimum of 50 liters per person is needed for health and sanitary standards. And in all fairness, the average American also uses over 300 liters per day. Palestinian water use continues to decline as the Palestinian population grows, forcing households to spend as much as 20 to 39% of their income buying water from Israel. Though that doesn't include all the water needed for agriculture or manufacturing. Palestinians of the Jordan River Valley have traditionally been farmers and herders, but they're currently unable to cultivate the land. By contrast, the access to water in Israeli settlements has allowed for high-tech dairy farms, vineyards, and orchards. Similarly, the part of Palestine called the Gaza Strip uses water drawn from the coastal aquifer located under the coastal plain of Israel and the Gaza Strip. But this aquifer is polluted from over-extraction and sewage infiltration, and it's estimated that 95% of the water supply is not fit for drinking. So as we saw in the American West, particularly for Native Americans still fighting for their water rights, discriminatory water policies and practices that restrict or deny people access to water ultimately block development and lead to unemployment and poverty. Political leverage and control over water like this is called hydropolitics, and it's one of the most difficult problems preventing a path to peace in the Palestinian-Israeli conflict, which is part of the broader Arab-Israeli conflict. Hydrological features like aquifers and watersheds don't often line up with political borders, and here in this part of the Middle East and North Africa, that's complicated even more by the fact that the political borders are also contested. So without clear spatial boundaries and with multiple layers of human-environment interactions, water access and water stress is a huge obstacle Palestinians face. Worldwide, there are 366 aquifers that cross boundaries, and the political, socioeconomic, and cultural difficulties between countries make sharing groundwater challenging. And aquifers are being pumped beyond their recharge capacities or contaminated when water percolating through the soil carries pollutants like fertilizers, pesticides, and feces and reaches an aquifer, which has huge ramifications for food security. Groundwater is largely unseen, but it may have the largest implications for all the ways freshwater intersects in our daily lives, from the water we drink and clean with, to the hidden freshwater that we need to process and produce a commodity. By measuring the commodity's water footprint, or even the groundwater footprint, we can see the amount of hidden water used. For example, beef cattle need 4,650 liters of water for us to produce a 300-gram steak. So when we eat high on the food chain, we're also drinking high on the water chain and placing enormous pressure on ecosystems, agricultural systems, and the communities who live where the product is actually produced. But any solution that would lead to sustainable groundwater use requires local and regional level cooperation, which continues to be a massive hurdle not just in the Middle East and North Africa. Each aquifer has a different set of social, economic, and political frameworks guiding how we value groundwater and regulate it. As physical geographers, we have just the right skills to observe and understand the physical processes at work that create groundwater and aquifers. We also have the tools to see how different spaces and places fit together on different scales. from personal water consumption to regional water sharing agreements. And human geography can help us understand how shifts in power across the watershed and aquifer basin over water rights impacts the cultural use of water, which we'll discuss more in the second half of the series. Next time, we'll see that water isn't the only resource that crosses boundaries and creates difficult geopolitical situations. The poles are thawing, changing spaces and places on the entire globe. Many maps and borders represent modern geopolitical divisions that have often been decided without the consultation, permission, or recognition of the land's original inhabitants. Many geographical place names also don't reflect the indigenous or aboriginal people's languages. So we at Crash Course want to acknowledge these people's traditional and ongoing relationship with that land and all the physical and human geographical elements of it. We encourage you to learn more about the history of the place you call home through resources like nativeland.ca and by engaging with your local indigenous and aboriginal nations through the websites and resources they provide.